grade. Today we are going to be taking a look at two sections, 4-2 translate expressions and also 4-3 evaluate algebraic expressions. You can go ahead and just lump those together in your notes and just do one section of notes for both. They go together really well. Our vocab, it's all found in section 4.3. We have evaluate, terms, and like terms. So if you would go ahead, pause your video, make your heading for 4-2 and 4-3, and then find these three vocab words, and then come on back to the video. All right, to understand where we're going in this section, the first thing that I want to talk about is what expressions are. Expressions come in two forms. We have numeric expressions and algebraic expressions. Numeric expressions have numbers and the operations. So remember that our operations are add, subtract, multiply, and divide. So a numeric expression just has numbers and operations. When we throw the word algebraic in front, that means now we have variables. So an algebraic expression can contain the same things a numeric expression has, which are the numbers and operations. When we talk about algebraic expressions, though, they have numbers, operations, and variables. So we're going to be working with both numeric and algebraic. They remind you about the vocab word evaluate that we had previously in the year. Evaluate essentially means you're going to solve it or you're going to find its value. So when it says evaluate, that chances are there's probably a variable in there. You're going to substitute for the variable and then you're going to solve and you're going to get your answer. Next two vocab words go together. We have terms and we have like terms. So terms are separated by operations. So if you have an expression such as 5 times 2 plus 3. That's a numeric expression. It has numbers, it has operations. This particular numeric expression has 3 terms. So the way that you figure out how many terms there are in an expression is to look for your operations. Your operations are what are going to be separating your terms. So in this particular numeric expression, we have 1, 2, 3 terms. They are all like terms because they're all numbers. We have no variables here. These are all like terms. When we think about like terms, usually it means we're talking about an algebraic expression. If it's numeric, they're all going to be like terms because they're all numbers. With algebraic expressions, though, if we put in some variables here, so we have this now, 5x, 2y, and 3x. Now we still have 3 terms. 5x is 1, 2y is 1, and 3x is the third term. When we talk about like terms, we can think of all of our terms as being names. So if you think about my family, we have 6 people in my family. We all have the last name Koenig. So there's me, Tracy, there's my husband, Kevin, and our children, Ruth, Jonah, Katie, and Simon. We all have the same last name, Koenig, okay? But we all have different first names. When you know that we all have that last name of Koenig, you can group us together. We're the Koenigs. Same thing with our terms. If our terms have the same last name, the same variable, they are like terms. And are like terms. Those things can be grouped together. If we don't have like terms, for example, this y here, if it has a different last name than our other terms, it is by itself. It doesn't have any other like terms. It's the only term with y. So now that we have talked about our vocab, we're going to go ahead and do some examples from 4-2. The first section here says write as a numeric expression and then compute. Now we are translating these expressions into math, and then we're going to solve. We're going to compute and see what the answers are. When you see a phrase like this, we've had shorter phrases that we've translated into math. Now you're seeing it's longer for start. Also, notice there are commas in here. The commas, just like in English, the commas in math are very important. What they typically mean is that whatever it's grouping together, whatever that comma is grouping together, is going to be in parentheses. So if we have 8 divided by 4, comma, that means that 8 divided by 4 is going to be in parentheses. So we're going to say 8 divided by 4 and put it in parentheses, and then it says plus 11. So plus, of course, means add, and we're going to add 11. We have our expression now. Now we can compute. So we say, okay, order of operations says we're going to do what's in the parentheses first. So 8 divided by 4 is 2. 2 plus 11 is 13. So my simplified answer is 13. Number 3, again, you see this comma is grouping this together. So it says 27 times 11. So we're going to do 27 times 11 minus 35. There's our expression. Now we need to figure out what our answer is. The first thing that we're going to do is work what's in the parentheses. So we have 297 minus 35. And if I subtract 35, we're going to get 262. All right, on to number 5. Number 5, you can see, is the longest expression that we've had. And we do have a comma that's going to group this together. There's something that groups over here too. So let's talk first about this group. It says 19 added to 21. So that's grouped together because of this comma. So we are going to put that in parentheses, 19 plus 21. And then over here it says times the sum of 3 and 5/10 and 11/100. When you see the sum of, or the product of, or the quotient of, that is signifying that whatever comes next is going to be grouped together. So this says the sum of 3 and 5/10 and 11/100. So that is also going to be in parentheses. And we do that. And then we're missing this word here, which is times. That means that we're going to multiply these two sets of parentheses together. We need to solve what's in the parentheses first. So over here we have 19 plus 21, which would equal 40. And over here, the sum of this would be 3 and 61/100. And then you can see I have to multiply these two numbers. So I'm going to write that this way so that I can drop this 0 down and then multiply. I have 2 decimal places in my problem, so I need 2 in my answer. So our final I just realized I wrote this problem wrong. Well, our final answer to this problem would be 144 and 4/10. Unfortunately, I skipped problems and combined 2 in the book. So number 5 was actually 19 added to 21 times the sum of 7 and 2. So much easier than this. So we'll change that out, and then this becomes 7 and 2. Still the sum of 7 and 2, which is probably why I made that error. So this would be 40 times 9, a little easier than that problem. So 40 times 9 would be 360. There we go. So the answer to number 5 is 360. The next section, our directions are write as an algebraic expression, use n as your variable. You remember in the last section, I think it was 310, where we had variables, the direction said use x as your variable. This time they're telling you to use n as your variable. Remember, if it tells you specifically which variable to use, make sure you're using that. If it does not tell you, then you can put in any variable that you want. So that's when you can use any lowercase letter. Important to remember here is we are going to have a variable, which means we're not going to be able to compute or evaluate. They're not telling us what the variable equals, so there's no way for us to solve these. You're just going to have an algebraic expression. When there's something that we don't know, so it might say a number, or it might say something like it does in this, the cost of a card. It doesn't tell us what the cost of a card is, so that's where we're going to put a variable. So we know the cost of a card is what we don't know. That's where we're putting our n. It's 6 times the cost of a card, and then you notice the comma. So we're going to group together 6 times the cost of a card. 6 times n. Sorry guys, my allergies are going nuts today. Of this expression says decreased by 5 cents. Even though this may not look like a traditional answer to a math problem, that actually is our complete answer. We have 6 times n, and we're going to subtract 5 cents from that. That's what our algebraic expression told us. So this is the correct answer here, and there's nothing else we can do for it. Number 9 says 100 less than a number tripled. So we have 100 less than. Remember that with subtraction, the order is super, super, super important. If we have 100 less than a number tripled, we know a number is going to be our variable. Tripled means that we're going to multiply that times 3. So I'm going to put the 3 in front, 3 times n. And then if we have 100 less than 3n, remember that that means we need to take our 3n first, and then we're going to subtract 100 from it. So this would be your final answer to number 9, 3n minus 100. You may notice that up here I put the dot showing multiplication, but down here I did not. Remember that you can show multiplication either with a dot, with parentheses, or if you have a number and a variable, you can just smush them together, and that means that you're multiplying. Traditionally, we put the number in front of the variable. Number 11 says 98 times the sum of a number and 1 3/10. So we have a couple groupings here, even though they didn't put a comma in, they did group because we have the sum of. So remember I told you that that creates a group when you have the sum of. So we're going to be adding a number, which is n, plus 1 and 3/10. That's grouped together because of the words the sum of. And then 98 times means we're going to be multiplying 98 times the sum of the number n and 1 and 3/10. You can, because this is in parentheses, you can just leave this 98 and then the parenthesis, that's showing that you're multiplying. If you want, you could put the dot in there. It's kind of further showing that we are in fact going to multiply 98 times what's in the parentheses. This is everything that I want to do in 4-2. So we're going to move on to some examples here from 4-3. 4-3, the first section tells us to evaluate each expression. So because we're dealing with variables here and because it's saying evaluate, that means that they are going to tell us what the variable equals. When you guys write these, I want you to write the algebraic expression that they give you. So we're writing that. And then beside that, I want you to write what the variables are equal to. So over here, we're going to say, well, P equals, Q equals, and R equals. And they tell us what they equal. So P equals 3, Q equals 4 and 2/10, and R equals 5 and 1/10. So we know that information. We have it right beside our algebraic expression. And now we can substitute in for our variables. So anywhere we see a P, we're going to change that to 3. Anywhere we see a Q, we are changing it to 4 and 2/10. And anywhere we see an R, we're going to put 5 and 1/10. So you notice everything else remains the same. So everything other than the variables is going to still be there. We still have 56 minus, we still have the parentheses, we still have this addition sign. What you need to do now is remember your order of operations. So order of operations tells us that parentheses come first. So first we're going to add these, and if you want, you can do that off to the side. And copy everything else down. Next, we're going to do this multiplication. Remember, when a number is beside parentheses, that means we're multiplying. So we're going to do that multiplication. And the last thing that we have is the subtraction. So we are going to subtract 56 minus 27 and 9/10. And remember that that placeholder 0 is super important because we need to borrow. And you can't do that unless you have that 0 there. Super common mistake would be to just drop the 9/10 down, but you can see that that would lead you to the wrong answer. All right, so our final answer for the first one is 28 and 1/10, and that is using the values for the variables that they gave us. If they hadn't told us what these variables equaled, it would have been like that last section in 4-2. We wouldn't have been able to do anything. Because there's no equal sign, there's no way to solve these unless they tell you what the variables equal. So you'll see they will tell you in these final sections with expressions, they will tell us what the variables are equal to so that we can substitute in and then we can actually get our answer. I'm going to do one more from this section, which is number 3. We have 15 plus CJ cubed. And they tell us that C equals 6 and J equals 5. When you look at number 3, I hope that the first thing that you notice is this exponent. Directly to the left of that exponent is just the J. Okay, it's not the C times J. If that's what it was, C and J would have to be in parentheses. Because they're not, directly to the left of that exponent is the J, which means that only the J is being cubed. So we have this. First thing that we would need to do here is the exponent because there are no parentheses. So we are going to have 5 cubed, which is 125. And then 6 times 125 would be 750. And then finally we would add these and get 765 for our final answer for number 3. When you look at the next page, page 127, this is where it talks about terms and like terms. So remember that like terms are going to have the same last name, which means they're going to have the same variable. And also, I didn't mention this before, but they also need to have the same exponent. So say you had one family called Smith, their last name was Smith, and another family's last name was Smithton. Those would not be the same families. One's named Smith, one's named Smithton. They're a little bit different. So similarly, if you have x, you have x squared. Yeah, they both have x, but they are different because if you have x, that's just x, right? But if you have x squared, that means that you're multiplying x's and you have 2 of them. So we have x times x. If we go back to the name thing, say we had Jones and Jones squared. Well, Jones is just Jones, but Jones squared would be Jones times Jones. So they are different. Even though the variable is the same, you have to watch out for the same exponents as well. So when we go to the next section, it says simplify by combining like terms, then evaluate the expression for the given value of the variable. So they do want us to come up with a simplified answer here. I'm going to show you number 5, and I'm actually going to show you 2 different ways to do it. So the directions said simplify by combining like terms. I'm going to show you what that looks like. This is probably the more streamlined way to do this, but there is another way to do it as well. So let's do this by simplifying like terms first. And they, of course, tell us what n equals because it's the only way we can do this. So by combining like terms, first I'm going to look for anything with the same last name. And you can see I have 2 terms that have n's in them. So when we have 2 terms that have n's, this term is telling me that I have 20 n's. And this term is telling me that I have 6 n's. So I always like to suggest you think about those magnetic letters that you played with in kindergarten and 1st grade. So you had those magnetic refrigerator letters that you could rearrange and make words out of. If you think about having 20 n's, so you took everybody in the class's n's and you had 20 of them in your hands. So you have 20 n's. And then you're going to take 6 n's away. So think about actually taking 6 n's, 6 of those magnet n's, out of your pile. How many n's would you have left in your pile? That's what this means. So we start with 20 n's and we take 6 of them away. So now we have 14 n's. Oops. We have 14 n's left. This minus 3, because it was not a like term, you cannot combine with the 14 n's. That's different. It's just a number, it's a constant. So we now have 14n minus 3. We knew that n is 2 5/10, so we can go ahead and plug that in here. Substitute in for n. When we multiply 14 times 2 5/10, we would get 35. We bring down the -3, and our final answer here would be 32. So our simplified version of 20n minus 6n minus 3, where n equals 2 5/10, is 32. Let me now show you a different way to do this. So here we combined our like terms and then substituted and then simplified. Let me show you what happens if we don't combine our like terms. So n is still going to equal 2 5/10. I'm going to go ahead and substitute that in here though. So now I am going to multiply, because order of operations says we multiply before we subtract here. So we're going to multiply, and this would be 50 minus 15 minus 3. And then I would subtract and subtract. Check it out. I get the same answer. So if you feel more comfortable substituting in and then finding out what the answer is, that's fine. You're going to get the same answer as if you combine like terms and then substitute it in and get your answer. This is way more streamlined. There was less math involved. So I do recommend combining those like terms where you feel comfortable doing it. If, however, that's confusing you, you're not sure how that's working, go ahead and just substitute in for all your variables and solve it out. You will get the same answer. You will. What I would like you guys to do now is to try some of these problems. Here is your assignment. We have from 4-2, page 124 to 125, 2 to 12 even, and then from 4-3, 126, page 126 to 127, 2 to 10 even. So this is your assignment. These are not due until next Monday, which would be So these assignments are not due until the 11th. We do have our Zoom this Friday, so if you have any questions, you could ask them then. Just make sure that you have your assignment submitted by May 11th.